Hey, Andrew. So my name's Noorvir. I'm going to present Unweave, which makes machine learning a lot less painful. Machine learning is pretty magical. As we've seen in the last few months, we have these amazing new image models, which take simple human language and convert it into fantastic imagery. But what if you wanted to do something like this from scratch? The truth is that you'd run into a lot of problems. And that's because often what you don't see is that behind these enormous models is a lot of backend engineering and tooling that make the barrier to entry really high. Even if you ignore the productionizing aspect of it and focus just on experimentation and tinkering, there's still a whole range of new tools that you'd have to learn just to get started. So this is what Unweave solves. Unweave lets you focus on your code while we figure out how to actually run it. So this is best explained through a demo. So here I have a terminal on my local laptop. If I look inside, I have a training script. I have some dependencies that have an Unweave store, which is where all our data lives. To run this with Unweave, we first need to tell it where to find the code. I can do it by doing Unweave link, and I'm going to link it to a project I created earlier with the same name. Next, I can run a command I would normally run on my local laptop, but prefix it with Unweave. In this case, I'm going to run it with a GPU, and as soon as I execute, Unweave will figure out how to build my environment, build it, and run it completely serverlessly in the cloud, and stream the logs back to my local laptop. We also have a dashboard, and I have the same project here as I have on my local terminal. We can do everything from the browser as you can from the terminal. So for example, we can look at the logs, the experiment I just ran. But more importantly, you can look at what data you ran with the experiment that you just executed. And this is really important in machine learning because you want to have a lineage of exactly what code and data you ran. So that when something goes wrong, you can go back in time and look at what data you ran with this particular experiment. So we're a team of two. I did machine learning for the last 4 years. And before that, worked in data engineering at Tesla. Mark worked in core Kubernetes tools for ML infrastructure. And before joining Unweave, he deployed AI models that served over 1 billion requests a day. We're in early beta, and we're actively onboarding users. And if you're an investor, we're also raising an angel round.
All right, good presentation, good energy. Now, tell us a little bit about, obviously this market's very crowded and there's all sorts of, people, there's CoreWeave and Banana and I guess, AWS. How are you different?
Sure, so a lot of the players in this market are focusing on deploying machine learning. So that's, so for example, Banana Dev, there's Sedon and so on. So there's a lot of these companies that are taking your Jupyter notebooks once your data scientist has prepared them and like deploying them somehow. Which is great. That's why we're not targeting that market. What we're focusing on is the training aspect, because one of the big problems here is that your data scientist runs a Jupyter notebook, trains something, and then hands it off to the dev team. And there's a big sort of gap in turning training environments into development. What we do is build your training environment, and so we know what the dependencies are. And so when it comes time to actually put it into deployment, we'll be in a really good space to give you a button which says.
Okay, just want to make sure I understand you properly. So you're basically saying there's companies right now that sort of help you deploy your Jupyter notebook, you run your experimentation in the cloud, good stuff. But those companies are actually not great, is what I'm hearing you say, at running those models like in stable production in a way that they're sort of natively integrated into your app. And you're sort of focused on that. Is that right? Is that a good distillation?
No, sorry, it's the opposite.
Completely different. It's a completely different company.
No, it's similar. It's those companies are focused on they do a great job in deploying it to production. They're very stable, but the issue is going from the training environment to the production environment. So that's not really possible to solve. So you need an engineer in there who converts from the data scientist's mind and his environment to taking it to giving it to the production team and some of these tools that will then deploy it into production. What we do is we give you training environments. We don't do any deployment. We give you a training environment, and because it's all automated, so every time you run something with Unweave, we build your entire environment so that if something's broken, it breaks right away. It'll tell you right away that, hey, your dependency is missing. So it never happens that you go to the production point and you don't have a dependency that you had locally. So that's what we're focusing on right now. We will eventually go to deployment, but that's a very crowded market, like you said.
Got it. So it's a bit more like Docker and a little bit less like Heroku. Is that right?
Yeah, exactly. So because it's machine learning, a lot of it is like very experimental. So you run an experiment, it doesn't work out, you throw it away, and 1 out of 100 works out, and you want to deploy that, and we help you sift through that. Because
Noorvir, tell us a little bit about why'd you start working on this?
Sure. So I worked as a machine learning engineer before this, and the way we collect data is by going to the lab space. It was a robotics company. we like either manually collected or there were customers who were streaming in their data. And it was really like, there's no workflow for where that data is being stored. How do you share it with your colleagues? And if you delete a file that you ran a model with, that sort of completely destroyed the whole workflow. What I really wanted was like to have my MacBook Pro have infinite processing power, infinite storage. And that's very much the vision of Unweave, that you should work as if you're on your local laptop, but all the tough part of like provisioning cloud compute and so on is completely abstracted away. But nonetheless, you can dive deep as much as you want. So we want it to be fully configurable, and you can dive down to the raw compute nodes if you want.
Noorvir, years ago, you worked at Tesla. Is there anything you sort of learned there that informs the way you do product development now?
Yeah, so the thing at Tesla was, or one of the things that was like an eye opener was how quickly they did iteration. So there was parts on the factory floor that went from like, instead of part A, B, and C, it was like A, B. So the number of iterations on cars going out there, that's very much what we're trying to do. It's, again, as a startup, there's lots of iterations. So we've gone through multiple different products. We initially started out doing only data versioning, kind of like DVC. But what we learned very quickly is you need your data and compute to sit right next to each other to really to take advantage of, like, firstly versioning, and secondly just like egress costs that are prohibitively expensive. So it's the iteration that Tesla is really good at, which I'm trying to now adopt it at Unweave.
Makes sense. Makes sense. Is there anything else that you think is really important for us to understand? You know, the machine learning landscape is unfolding so quickly. There's new sort of seems like every single day there's a new breakthrough. I imagine you're sort of closer to this than most. Sort of, yeah. Help us understand how, you know, where things are going and sort of where Unweave sits in that broader story. Like, given, you know, where the world of AI or ML will be in 3 or 4 years, sort of what do you think is going to be different about that reality than today, and how do you fit into that?
Sure. So one of the things I mentioned early on the slide is when you train these enormous models, like the models behind the algorithm behind them is really like simple. It's not easy, but it's very straightforward. It's a transformer that has lots of data that comes in and pushes it up. But there's a huge amount of engineering effort that takes into, you know, training these models in a distributed manner. Each one of those trainings costs like hundreds of thousands of dollars, if not millions. That cost will come down, but the engineering effort of distributing these compute loads across multiple nodes and so on is still like a really big engineering challenge. So that's what we're trying to solve. We're trying to abstract away all the engineering you'd require, the data engineering team and the infrastructure team you'd require to train a model like this yourself. It's very early days, so right now we're sort of only on a few GPUs at a time. But that's where we want to go. That you as an engineer or like a newcomer to the field, take your laptop, you dump some data onto it, and you can really rapidly iterate and take the last output and pump it into something new.
A question that's sort of unsolved, I think, in the machine learning sort of Cambrian explosion today is what sort of ML APIs look like. Meaning, if you look at OpenAI, it's sort of like a very simple API where you put in text, you get more text, maybe a little bit of fine tuning. And if you like look at Stable Diffusion, where there's open source stuff, you could sort of see a simple API is sort of not what people want. And they want something, everyone sort of wants to slightly train their own model. But then again, you know, training your own model from scratch is also really complicated too. And I guess when databases were getting really big, it was nice because it was just really simple abstraction. There was SQL. And so like everyone understood sort of how to plug into a SQL thing. What do you think is going to happen with ML? Like, how is this all going to fan out? Do you think that we'll be using relatively simple APIs like what's offered by OpenAI, or do you think will everyone train their own model? If something in between, what does that something in between look like?
So far, I think the fine tuning. I don't know any models that won't require fine tuning for something that's not a generic.
Okay, so your view is that like there'll be base models. There'll be base models that you go and get, and then you sort of fine tune it on your bespoke case, and that's sort of the equivalent of SQL.
Yeah, in the near term, at least, it's moving so fast that in 10 years, maybe you have a model that does it all. I really couldn't predict that. But for the moment, maybe not for image generation, for example, but if you're, for example, the last company I worked at, like a robotics company that wants to weld a joint on a very specific looking part on a car, like you don't see that part very often. So you take some model that's really good at detecting, like flat surfaces and fine tune it to your particular use case.
Yeah.
And what we're trying to do is make that part really easy. So we have one of the things that in demo is you can take a Git repo and deploy it really quickly, or like create a training environment with it really quickly with Unweave with like a couple of buttons, and we figure out how to actually run it.
Makes sense. Makes sense. The era of sort of everyone training their own model might be peaking, but the era of everyone fine-tuning their own model sort of might be still growing. I think it's a good view. Thank you so much for taking the time. Good stuff, good product. And best of luck.